Hey, Accelerator Algebra 2 Stirrup here. So we want to just go over this 6M, see how we do. So let's continue with what we know about the solutions, but let's see a couple of the things. So first thing we need to remember is the i's. So if we had square root of a -1, that's equal to -1. That's equal to -I, and that's equal to 1. So that all exists. So if we simplify this, that gives me 3 times -1, which is just -3. So that's actually a real solution, even though you have an imaginary component. And then we'd have 16i squared. I squared is -1, so we get -16. On this one, that's going to give me -8i to the third. I to the third is -I, so that gives me 8 positive 8i. This one is going to give me 81 I to the fourth. I to the fourth is equal to 1, so it's 81 times 1, which is just 81. All right, so what are the solutions for the following? So this first one, we would subtract 36 from both sides, and then take the square root. Don't forget the plus or minus, so you get x equals plus or minus 6i. Next problem, same thing. I'm going to subtract 2 from both sides. Take the square root. Don't forget the plus or minus. So x equals plus or minus I root 2. All right, so can we predict the number of solutions for a polynomial? Yes. So that's based on the highest degree. No matter what order it's written in, the highest degree determines how many roots you could have. And I use the word could. Okay, what should we consider? Again, consider the highest degree. Okay, so find all the solutions, both real and imaginary. So the first one, that's just basic algebra 1. Just add 1. So we'd have a solution of 1/2 there. Pretty easy. That's a real answer. It's a rational answer. Next one, I'm going to add 2 to both sides. Take the square root. Don't forget the plus or minus. So this is a real answer. It happens to be irrational. Irrational means that we know about where it crosses the x-axis, but because if we took the square root of 2, it's a continuous, non-repeating decimal. And then this one, this is the difference of 2 cubes. So it's going to be this. So this is going to give me x equals 2. So you have a real solution here. This, for the most part, will give us 2 complex answers, okay, for the most part. Now, it could also be 2 irrational. But what you could do on this one is, you know the quadratic formula. Well, you know that b squared minus 4ac, that's underneath the radical. So if you plug that in and we get a positive number, it'll be irrational, meaning it'll be a decimal, goes forever. So 2 squared is 4 minus 4ac. So I get 4 minus 16. So I get negative root 12. Well, that means we have 2 complex, because that's going to give you an imaginary component answer. Or your conjecture for the relationship between the degree of a polynomial and the number of solutions it has. Well, if it's third degree, we can have 3 solutions. And that solution could be real. And in the real numbers, you have rational and irrational. Okay, those are subsets of the real. Or they could have complex. Now, here is the news on this. Remember I said complex always come in pairs. Complex are always conjugates of each other. A plus I and A minus I for the most part, in the simplest terms. So that means if there's 3 solutions to this problem, 2 of them could be complex. If 2 are complex, that means 1's real. Now it's possible all 3 are real solutions, but we'd have to use our synthetic division to go through and check that. Oh, I got stuff to erase on this one. All right, so let's see what they have here. Bet you guys wish you had this kind of fun thing. Okay, so function at x is a polynomial of degree n, so n just represents the highest exponent, where n n where is greater than 0, okay, so we don't have any negative exponents, then the equation f at x equals 0 has at least one root in the set of complex numbers. Ooh, there we go. So how many solutions do these problems have? Okay, so what I'm going to do is I'm actually going to write these problems down, and I'm going to go into Desmos because it's a useful tool for us, and I want to show you how this is going to work. So this, number 7 should have 3 solutions. Well, let's go into Desmos and take a look at it. So I want to graph y equals x raised to the third plus 3x squared plus 16x plus 48. Okay, now here's the beautiful thing. I could zoom out and see if this graph is doing anything. And I'm going pretty far out. It doesn't look like a whole lot's taking place. So what I know right now is if I go to this point and I click on it, I get the point -3, 0. So that's obviously a real solution. Now, I zoomed out pretty far, but it's not to say that this graph wouldn't go cross elsewhere. But let's go back to our graph and just take a look at it. So we know that -3 is going to work. So I'm going to go oops, change that to a pen. -3, because we knew that worked, and I'm going to use all my coefficients. I don't have any holes in it, so I'm going to just use that. What this is going to allow me to do is going to allow me to get this down to a simpler form. See, I could perhaps factor it. Okay, so we did this the other day. This was degree 3 originally. Now I've synthetically divided it, so I can go x squared plus 0x plus 16. So x squared plus 16 equals 0. Go ahead and solve that. So x equals plus or minus 4i. So those are 2 complex, okay, and 1 real. If I go 2 plus 1, I get 3, and that's what should happen. Okay. Let's see. I'm going to skip this next problem because I don't know what this C is representing right here. So it might be a misprint. So we'll just skip it rather than dealing with the frustration of it. Okay, so find all the zeros of this function. Again, I'm going to write this down on a separate sheet of paper so I can jump into Desmos. So it's raised to the 5th power, so that means there should be 5 solutions to the problem. Now, you could have 4 of them that are complex, you could have 2 of them that are complex, or you can have none of them complex. So that means you can have 5 real and no complex. You could have 1 real and 4 complex. You could have 3 real and 2 complex. You can't have an odd number of complex, okay? So I'm going to go ahead and graph that on Desmos. Let's get rid of this one. So I get y equals x to the 5th minus 2x raised to the 4th plus 8x raised to the 2nd minus 13x plus 6. Ooh, all right. So my friends, so right here, this is taking place at -2. That's great. But now we have a bounce here at 1. There's a bounce. So remember, a bounce happens if it happens there 2 times or 4 times or 6 times. So it's very possible we have 1 real solution because a cross happens only once. If we had a wiggle, it would be 3 or 5 or something like that. But we don't have any wiggles, but we have a bounce. So that bounce, being this is raised to the 5th power, that bounce could have happened. We could have the binomial x minus 1 raised to the 4th power is very possible. Okay, so but it also could be just twice happen there. Okay, so we're going to go ahead and use both of those on our problem. So we're going to start with the negative 2. My music stopped, so sorry. I always listen to music while I'm playing. I don't know if you guys have figured that out yet or not. All right, so we're going to use negative 2 because we saw that happened there once. So I have 1, a negative 2, and 8. I don't have any holes. Oh, I don't have, that should be a 0 because I don't have an x to the third. 8, negative 13, and 6. Okay, so I'm going to bring that straight down. 1 times 2 is negative 2. That gives me a negative 4. That gives me an 8. Add those. That's going to give me an 8. 8 times 2 is negative 16. Bring that down. That's going to give me, let's see, that's going to give me a negative 8. 8 times 2 is 16. There, negative, negative. That gives me 3. That gives me a negative 6. So beautiful. We have that 0. So we confirmed this as a solution. That means this refers to x plus 2 as the binomial. But the solution is at negative 2, 0. So that results in negative 2 comma 0. So it's a solution across the x-axis. We confirmed that. Now, I can use synthetic division, but I'm going to use synthetic division on this divisor. I'm not going to worry about the 0, just the number parts. Okay, so I'm going to go, I want it to divide, remember I had the bounce, have it at 1, so I got 1, negative 4, 8, negative 8, and 3. Bring that straight down. 1 times 1 is 1, that gives me a negative 3. Negative 3 times that is negative 3. Straight down, that gives me 5. 5 times 1 is 5. That gives me negative 3, which is negative 3 here. Gives me a 0. Okay, that confirms that x minus 1 is a solution. So we have 1 comma 0 because of that. Now remember we had a bounce there. So I'm going to take this here and synthetically divide that. And I'm going to use 1 again. 1, negative 3, 5, and negative 3. I got 1. 1 times 1 is 1. It's negative 2. That gives me negative 2. That gives me 3. 3. I get a 0. Awesome. Okay. So again, this confirms that x minus 1 is the binomial factor, which gives me the point 1 comma 0. Because I have this and this, that verifies that the bounce took place. Okay, because x minus 1 times x minus 1 is x minus 1 quantity squared if we leave it as binomials. Yes, we could FOIL it together, but we don't need to. Now, we have a couple of thoughts we could go with here. We could try 1 again, because remember I said it could happen 2 or 4 times. So let's try that one, see if it happens one more time. If it doesn't, then we're going to go to another route. So that's 1. 1 times 1 is 1. That's negative 1. Add those together. It's negative 1. 2. Okay. So that verifies that we don't have 4 times happening at 1 comma 0. Only twice. All right. So I realize, let's see. Let's follow my math here. So this started out with x to the 5th. Then this became x to the 4th. This became x to the 3rd. This became x to the 2nd. So I get x squared minus 2x plus 3. That's not going to factor, is it? Let's see. No, I can't factor that. So now we have to think about how do we want to solve it. I'm going to use a quadratic. So x equals negative b. So negative negative 2 is 2. Plus or minus negative 2 squared is 4. Minus 4ac all over 2a, which is 2. So I get 2 plus or minus 4 minus 12 over 2. So I'm going to get 2 plus or minus root negative 8 over 2, which is going to solve down to 2 plus or minus 2I root 2 over 2, which then that reduces all those. So I get 1 plus or minus I root 2. There's 2 solutions. So I have 2 complex solutions. I have a real solution here, a real solution here, and a real solution here. So I count 1, 2, 3, 4, 5. It was raised to the 5th. That worked. Cool. Oh, I get more erasing. I'm going to make a bigger eraser, though. Okay, this is what we've been saying for a while. A plus bi has to also have a minus bi, and a plus bi and a minus bi are the conjugate pairs. They always exist when you have complex numbers. You always have two of them, and they're opposite pairs of each other. So you'll have a positive and a negative component in them. Okay, so find all the zeros of this function. So I'm going to write this one down. We'll go to Desmos real quick. Go back to Desmos. Okay, so notice we have a solution here, -1, and we also have a solution at 2. So we're going to hold on to those for a little bit. And being it's to the 4th power, if I divide by both of those, it'll take it down to the 2nd power. So there's no reason to like zoom this out a billion times to look for it. Okay, so I know that -1 works. So we got 1, -1, 2, -4, -8. Bring that down. Add those. Oop, -8. Sorry about that. And then it gives me an 8, which then gives that to be a 0. So that verifies that we have x plus 1 as the binomial and -1 comma 0 as the solution. Okay, so this is now x to the 3rd. So we already said that 2 should work. So let's see if we do this. Bring that straight down. 1 times 2 is 2. Add that. That's 0. 0 times 2 is 0. Add those. I get 4. I'm ignoring that because I don't need the last 0. That's a 4. Sorry. That's going to give me an 8, which is going to give me a 0. That also verifies. So remember, as I was going through this was x to the 4th here. So this is x to the 3rd here. This is x to the 2nd. So I'm going to wind up with x to the 2nd plus 0x, so plus 4. And if I solve this, I'm going to get x squared equals -4, x equals plus or minus 2i. So those are my two complex or imaginary numbers. And then I have 1, 2. So I got 1, 2, 3, 4. There's my 4 solutions. So again, Desmos is a valuable tool, and it works on your graphing calculator as well. But Desmos is pretty easy because we all have it. All right, so they tell us we have zeros of this. So that gives me x minus 3, x plus 4, x minus 5. Okay, so if we were to multiply these together, I'm going to FOIL that. That's going to give me x squared plus x minus 12 times x minus 5. Distribute the x, so I get x to the 3rd plus x squared minus 12x. Distribute the -5, -5x squared minus 5x plus 60. Combine like terms. So this is the polynomial that was referred to with those zeros. So if you use synthetic division on these, you'd have a remainder of 0. All right, so this one. So this is going to give me x plus 3. This is going to give me x minus 3. If I put those together, 3. That's going to give me x squared minus 9, difference 2 squares. That's going to give me x minus 5i. And that's going to give me x plus 5i. Okay, see how it's opposite because it would have been equal to 0. If I FOIL this, I'm going to get x squared. The outside and the inside cancel each other out, so I get minus 25i squared. We said I squared is -1, so that's x squared plus 25. So now, if I multiply these two together, so x squared times x squared is x to the 4th. X squared times 25 is 25x squared. -9 times x squared is -9x squared. And -9 times 25, what is that, -225. Combine these like terms. plus 16x squared minus 225. That is the polynomial. And again, remember we had 4 zeros. It's raised to the 4th power. All right, on this one, the trick on this one, they often give this to you, is you have to realize negative I also takes place. Okay, so this is going to give me x minus 4 and x minus 4. And if I FOIL that together, I'm going to get x squared minus 8x plus 16. And if I FOIL these together, I'm going to get x minus I and x plus I. So if I FOIL this together, I'm going to get x squared minus I squared. So that's going to give me x squared. Negative I squared is positive 1. And then I'm going to multiply these two together. So I'm going to wind up with x to the 4th minus 8x to the 3rd plus 16x squared. Distribute the 1 now. Plus x squared minus 8x plus 16. And combine like terms. So I get x to the 4th. And I only add the x to the 3rd, so we're good there. I have x to the 2nd, so that's plus 17x to the 2nd, minus 8x plus 16. So this polynomial here, 4th power, has these 4 solutions. So you have to realize that I and negative I have to come together. Okay, that's it. Why don't you take a look at the homework and see how you do. Try the odds. And have a great day, everybody. Take care of one another.